So, here's a question for you. We all know AI is getting ridiculously good at recognizing pictures of, well, pretty much anything. But can it see the world the way a scientist does? Can it pick up on those tiny, crucial details? Today, we're going to dig into a brand new test for AI called INQUIRE that tries to answer that exact question.
First, to really get why this is such a big deal, let's start with a challenge. A search that would be pretty straightforward for a biologist, but turns out to be almost impossible for some of our best AI.
Okay, imagine you're a scientist. You're not just looking for a bird's nest, you need to find a photo of a satin bowerbird's nest. And this is the important part, it has to be ornamented. You see, this bird is famous for decorating its nest, and that's a key behavior. So the AI doesn't just need to know bird and nest, it needs to understand the very specific concept of ornamentation. That's a whole other level.
Or let's try this one. You need a picture of a Tamandua pup. Easy, right? Nope. You need a picture of a Tamandua pup being carried on its mother's back. Now the AI has to understand a relationship between two animals, a specific action, being carried, and their exact position. It's way more complex than just identifying an object.
And that's really the heart of the issue, isn't it? Searching for cat on the internet, AI has that down. It's a solved problem. But scientists are searching for incredibly specific behaviors, life stages, and rare events. And for that kind of work, our current AI tools just, well, they're not quite there yet.
So, why is there such a huge gap? Well, it turns out the tests we've been giving AI to measure how well they see have gotten way too easy. It's like giving a PhD student a multiplication table test. Of course they're going to ace it.
And hey, don't just take my word for it. The researchers who built INQUIRE say it themselves. Our best AI models are getting pretty much perfect scores on the old benchmarks. Which sounds great, right? But what it really means is the tests aren't challenging them anymore. We're not learning anything new about their limits.
And this table really just puts it all into perspective. Look at the old datasets. Flickr 30K, Coco. They have maybe a few thousand images. INQUIRE, it has 5 million. And maybe even more important, the queries are designed for experts. This isn't just a bigger test, it's a fundamentally harder one. It's a whole different league.
And boom, this number says it all. This is the score a top-tier AI, Blip2, gets on that old Flickr 30K test. 98.9%. I mean, when all your students are getting an A+, it doesn't mean they're all geniuses. It means your exam is too easy. It's time for a new one. And that's precisely what INQUIRE is. It's the new final exam. It's brutally difficult, and it's designed from the ground up to push the most advanced AI vision models on the planet to their absolute breaking point.
So, to put it formally, INQUIRE is a new benchmark for text-to-image retrieval. But what that really means is it's a massive collection of 5 million images from the natural world, paired with the kinds of tricky, expert-level questions that scientists ask all the time.
And the questions they're asking aren't just random. They fall into these 4 big categories that scientists really care about. Things like the specific appearance of an animal, its behavior, the context of its environment, and, of course, just identifying the species. Now, the way they test the AI is actually pretty clever. They do it in 2 main ways. One is just a massive brute force search across all 5 million images. The other is a more subtle task they call a re-ranking challenge, and that's where it gets really interesting.
So check this out. This re-ranking idea is so smart. It's a 2-step dance. In step 1, you use a fast, kind of good AI to do a quick and dirty search. It pulls the top 100 possible matches from the giant pile. Think of it as the intern doing the initial research. Then, in step 2, you bring in the expert, a much more powerful, slower AI, to just look at those 100 images and put them in the perfect order of relevance. It's a brilliant way to get both speed and accuracy.
All right, so this is the moment of truth. We've got this super hard exam designed to challenge the smartest AIs. How did they do? Let's take a look at the report card.
And wow, this is the big takeaway. The best model they tested, even the mighty GPT-4o, scored just under 60%. I mean, that's a failing grade. It's not even close to a perfect score. It just goes to show that having a ton of general knowledge about the world doesn't automatically mean you can understand the very specific visual language of science. There is a huge gap here.
So that score immediately begs the question, right? What is it about these scientific questions that makes them so tough? Why are even the best of the best AI models hitting a brick wall? Well, a huge piece of the puzzle is the language itself.
Scientists have their own lingo, right? Very precise, very technical terms. But most of these big AI models are trained on, the entire internet, not on scientific journals. It's kind of like asking someone who speaks casual, everyday English to suddenly read and understand a complex legal contract. They just don't know the vocabulary.
And this slide is the perfect example. A scientist might search for accentism in a green frog. To an AI, that might just be a string of nonsense words. But what it actually means visually is a frog that has a mutation that limits yellow pigment, which makes it look blue. The AI has to connect that technical term to a visual reality. And right now, that's a massive leap for them.
What's also fascinating is that the AI isn't equally bad at everything. It's actually pretty good at spotting things related to human impact, like a picture of a leopard on a road. But where it really falls apart is with things like life cycles. For example, telling the difference between an immature bald eagle and an adult. They look completely different. That requires some seriously deep, specialized knowledge.
Okay, so at this point you might be thinking, cool, we built a test that can stump an AI. So what? But this is so much more than just an academic game. This matters because of what it could unlock for science and for all of us. The whole point of this, as the researchers say, is to close the gap. It's about building AI tools that scientists can actually use in their day-to-day work. INQUIRE isn't just a report card on where AI is today. It's a roadmap for where we need to go next. And just take a second to think about what that future looks like. An AI that can see like a scientist could help us track biodiversity at a scale we've never seen before. It could automatically analyze animal behavior just by looking at millions of tourist photos. It could help us track how habitats are changing over time. We could make discoveries so much faster. The potential is just enormous.
And really, it all comes down to this one big, fascinating question. We're teaching these machines not just to look at pixels and identify objects, but to understand context, relationships, and behavior. To truly see the world in all its rich, messy complexity. And once we get there, what new secrets about our planet will they help us discover?